on the finals. So this is the final review on the final exam. So the final has been written. The final exam has been sent to the printers. So what I'm looking at as I go through these questions, explaining what they are, is exactly what's on the final right there. So as I go through and I outline the final exam, that there. Now, earlier today, I was reviewing for the final in microcontroller, and I'm going to go ahead and keep talking. I don't know what you guys are chit-chatting about, but you can watch the recording later for this information if you. That's there. I was told, but I've got for your final exam, I've got May 27th at 9 a.m. Is that right? So that's the right time, okay. Because I know the final exam for the microcontroller evidently was changed from the time I wrote that there. So you've got a good 3 weeks between now and the final. So you got plenty of time that there. We're not meeting next week, and then you got review week, and then you've got the first week of finals. We're the second week of finals. So you've got a lot of time between now and the final. So, and the only reason I bring that up is I'm going to tell you what's going to be on the final exam, and having 3 weeks between now and the final is a good and a bad thing. It's a good thing is you've got plenty of time to study if you don't that there. But what makes the bad thing is if you don't look at it between now and then, you've got plenty of time to forget everything that I'm going to tell you in the next 30 minutes. Isn't that there? So between now and May 27th, I strongly suggest that you go back, look at this lecture again, kind of make sure you know the answers to all the questions, because I'm going to give some of the answers today or know where to find them. And if you need clarification, I will be around. I've told my other classes that I'm not a really good employee at times. I'm not here from 8 to 5 like the boss says we're supposed to be, although the boss himself sometimes is just as bad as the rest of us. But I think the only person that's here 8 to 5 pretty much every day is probably Dr. Ibrahim. He's pretty steady. But he's single and he lives by himself in a studio apartment. He says if he goes home, what does he do? So he likes to hang around here. I've got my wife, I've got TV at home, I got other things to do. So plus I have my own office at home that's a little bit quieter and easier to work in. So I tend to stay home more than not there. So if you have questions on the final between now and then, and you want to see me, you may want to touch base with me first to make sure I'm going to be around. That there, because I will come in to meet students. That's what well, welcome. Now the core of our course is here. That there. So, but if you want to meet between now and finals, the day of the final, and I'm not around, just text me. And I live 15 minutes away from here, 10, 15 minutes. If you text me and say 8, 9 o'clock in the morning, say, can you come in today? We'd like to meet with you. And say 11 o'clock, I'll come in. It's no big deal. I live close enough, and that's there. And I'll be happy to come in if you've got questions out there. So don't think that just because I'm not around that you can't ask questions. Just ask me to come in out there. So otherwise, I'll just stay at home and work on the robotics class. I'm teaching it the short semester, and they did deliver one. Our new guy played with it a little bit. He couldn't get to work. I went over and sat in his cubicle for a while. I was able to communicate with it and move the arms using MATLAB. So there is some hope for the robots that they sent us, but it's still the same scheme. It's still the way that they work is you set 3 commands for every move: speed, motor, and angle. But the difference is that I can stack 30 movements into one M file and have it execute the M file right there. Where before with the little handheld thing, every move was a set of so it is easier to program it there. We can actually write programs, but the programs are at very low level. So I don't see this class doing a lot of major programming with that thing. because it's very low level. But I'll be writing some labs for that. Okay, let's talk about the final. I know that I reviewed for it before, but I'm going to review for it again. I'm going to probably just go through it. I'm going to go through it question by question, just tell you what they are right there. I won't necessarily tell you the exact questions, but I'll give you a hint at what they are. A few things about the final exam is it's 5 questions. You must answer 5 questions right there. So there's no 5 questions, pick 4 of the 5. You have to answer all 5 questions out there. So, and I know that some people, it's kind of a Malaysian tradition. I remember when I was here the first time back in 98, 97, the first time I wrote a final exam, somebody was going through and looking at it, made the comment and says, don't you have, pick 20 questions out of the 30 questions, or don't you have pick 4 questions out of the 5? It's, no, I want to answer all of the questions. They looked at me like I was brain damaged. That there, I get that look all the time, from various people. Unfortunately, what we've kind of gone to, and I don't know if all the ICO lecturers do it, but the way that they're forcing us, the EAC, the Engineering Accreditation Council, EAC, is making us do what they call assessment of whether our students learn things. We're forced to have students answer all the questions out there. That's just the nature of how things are. So, okay, the questions are fairly basic out there because we didn't do a lot of specific stuff right there. So, as I go through and I look at question 1, that there, we talked about 3 of the various types of motors: servos, steppers, and DC motors. We didn't talk much about pneumatic and hydraulic motors, but they were mentioned right there as far as actuators are. And basically, you have to explain how they work and that type of thing. There are questions mentioned and explain the various types of motors for robotics, including that there. So it's an essay question that you just put down what you know right there. That there. So I would suggest that I give you the hint: servo, stepper, and DC were the ones we covered in class. So which one's more expensive, which one's more accurate, which ones can you use feedback with. But you answer that question. It's an open-ended question right there. So and at the end, I'm going to look at your answer, and I have 9 marks next to it, and I'm going to decide how many of the 9 marks to give you for your answer. I will say that there is no right or wrong answer. This is an open-ended question, so you can answer that question however you want. Question 1B is very similar. I talk about what's the difference between rotational and revolving joints, the different types of joints. I may mention, others mentioned as well, but in other words, what type of joints they are. We went through a set of slides early in the semester, and again, they're listed on Facebook, where all the various joints are, and I just picked 2 of the different types up there. And part 1C is one that I talked a little bit about multiple times in the course. And question 1C is a sociology / economics / whatever you want it to be question, where I say, I'll just tell you the question: discuss the various advantages and disadvantages of factory automation, and then I say should include economic, technical, social, and all those various things. What effect does converting to factory automation have on the efficiency, the economics of the plant, the quality of your product, whether or not it's a lesser or greater quality, the effect on the economics, the economics of the community around the factory, what effect does it have on crime, for example? And you could pinpoint cities such as Detroit, Michigan, in the U.S. and talk about, I don't think I mentioned Detroit in particular, but Detroit is the U.S. center of automobile manufacturing. Matter of fact, there's a whole class of music that came out in the 1960s called Motown, which is, Motown means Motor City, or Motor Town, which is Detroit, Michigan, and it was mostly black rap or black music that was very popular, but it was called Motown music, and there was actually a record label called Motown out there. And Detroit, used to be a very booming, very economically viable city with lots of things happening. The last 10 years, Detroit has become basically a dump out there. And I have a son that lives in Detroit. And, when I go up and visit him the last time, I mean, you saw entire city blocks that were shut down because the factories had closed and people had moved out, and you could buy houses for $1 out there. I mean, literally, you could buy a house for $1 because it was in a community that nobody wanted to live. So, I mean, the city was practically, we were giving away houses. All you had to do is pay the city taxes on it every year. Out there, you'd have to pay the back taxes and fix it up and move in. It's your house. And this was a house that probably 3-4 years ago, 5 years ago, might have sold for $150,000 USD. And now it's worth $1. And the big difference is that factories had started automating and laying people off, and jobs became harder to get, and the entire town became very depressed out there. So, again, problem one is a open-ended problem, all three parts. I can tell you the questions, and you have between now and May 27th to kind of research what you're going to put down for the answers, because I just told you the questions. Parts 1 and 2 are very specific in terms of different types of motors, and motors is part A, part B is joints right there, and part C is a open-ended question. What happens, discuss the advantages and disadvantages of factory automation. I left the word out there, factory automation. You should include in your discussion economic, technical, social aspects shifting from manual, right there. In other words, what happens as you go from manual operations out there. So there's a whole list of things. So question 1 is a difficult question for that there, because I can tell you the questions, but there's 6,000 different answers you can write for that there. Not any of them are wrong out there, but some of them are probably going to earn more points than others in terms of how much thought you put into your answer and that there. So, and I talked about all those subjects during the course at one time. So now it's the time to see whether or not you're listening, because I can't. That question's hard because I can't point to a PowerPoint slide and say the answer's right here. I discussed all those points over the last 12, 13 weeks. That there. So, question 2. These are much more specific, and they're short answers right there. And it's a fairly easy question that there. Part 2, everyone should probably do fairly well, because I'm going to ask you very basic questions. How do you set the position of a servo, standard servo? How do you set the speed and direction of a continuous servo? How do you control the speed and direction of a various motor controls? What does an H-bridge do? What's open-ended or closed-ended? So it's very specific type questions right there. And you might want to review what I just said, because I just read off the various parts of that question there. So, So I talk about standard servos, I talk about continuous, I talk about H-bridges and DC motors, and I talk about open and closed loop control. So it has to do with those 4 topics right there. And again, they're not open-ended. I don't say that there. I just simply say, how do you control a continuous servo? And continuous servo can go clockwise or counterclockwise out there. And how do you get to go clockwise or counterclockwise? How do you vary the speed? And I did a demo with the Arduino, as I recall, on both the servos, on the servos and the H-bridge right there. Some of you are taking feedback control right now, so the last part of that should be an easy problem, because it's, what is feedback control and how is it different from open control? Question 3 is very much like question 2, is that, or question 1, that there, I list all the various sensors and explain the following types, along with an example of where each is used. And I'm not going to list the sensors, I'll let you look that up. But I've got 4 sensors listed. They're all in that first book that I used, where I went through the various sensors right there. And so so part 1 of question 3 is knowing what the various sensors are. I'll tell you one, a velocity sensor, right there. So, so I want you to go back and read up on the various sensors that were covered. And I put a book up early in the semester, not the textbook. The textbook we threw away day 1. That second book that I put up there that I used for like 2 or 3 weeks. That's where that question came from, right there. And then the next one is, I just give you an example, and I'll tell you this example I showed you the video on. It's that little car running around on the track, and I would say, you explain how you would set that up, how you would build that. Again, that there is an open-ended question. Explain how you would control the motors of a self-driving car. Assume that you have 2 drive wheels using standard motors. Assume that it's going to follow a track. How would you? What sensors would you use? How would you control the motors? It's an open-ended question, a difficult question, not there. So, again, I'm not asking you to design it, write code for it. I'm just asking you how would you do it, not there. If you want to include block diagrams, which probably make your answer clearer. If you want to include, kind of a picture of what the car might look like when it was done, if it would make your answer clearer, that's perfectly fine. But the whole idea is that at the end of that reading, I've got 8 points, and I have to decide how well you would get, how well your mind would think about how you would do this car, right there. You're thinking as an engineer there. So that's problem 3. Problem 4 is a PLC problem, right there. And part A is basically starting and stopping a motor, and that there. So that there. So it's a very simple one. Part B, I add something to it that's relatively straightforward. Part C, I ask you about the anti-tie-down circuit, what it's used for. I don't ask you to design it. I just ask you the reason, what it is, and why we use it, right there, type thing. So, and then I give you a circuit. It's a relatively simple circuit, and you're supposed to just tell me what it does, right there. So it's a PLC circuit. So, I'll tell you right off that there's a motor that goes on. There's a start and run, right there. And part 5 question 5 has got 2 parts. And question 5 is probably the most difficult question on the test. That there, because it's strictly 2 separate PLC design questions, right there. So that there. So, and I'm not going to tell you what they are, but you've seen similar ones out there. But basically, it's construct a PLC with the proper interlocking for that there. And what it is there's that there. One is going to require the use of a timer, right there. So there's 2 parts of problem 5. One part is a straightforward PLC that doesn't require any timers. All it has is push buttons and outputs right there. And of course, you can use the motor running, for example, as one of the controls. But the second part does require a timer right there. So, and I actually think we talked about this, the part 5B, I think I actually talked about in class, maybe even did it, but I can't remember that there. So, but I know we covered that. Part 5A I did not do in class, so that one's you're on your own on figuring out how to do that one. That there. One of the things that I like to do on final exams like this, and I'm doing it more now than I actually did in the past. That there. You caught just as I'm kind of wrapping things up here a little bit, but I recorded. I gave all the answers to the final, didn't I? So, they may not share them with you. You didn't come, so you don't know what's going to be on the final exam. That there. Actually, no, I recorded it. So that there. But one of the things on the final exam here is that you need 60% to pass the course, right? 40% most of you got already because the projects I gave were fairly straightforward, and you've been hard unless you worked in groups. It'd been hard not to get all 40 points that there. So you really only need 20% to pass the class on the 20 points out of 60 on the final exam. So if you got 33% of the final exam right, you still can pass the course, right? That there. So I would say that 60% of the final exam is fairly easy, and if you're halfway awake during the last 12, 13 weeks, you should be able to get at least 30%, 40% of the final exam without that there. And probably 60% of the final exam is fairly straightforward. But if you slept a little bit and didn't really study, you might miss a few. So, the worst anybody should get on this final exam, if they showed up and listened to the lectures and didn't sleep too often, that there didn't read Facebook, you should at least get a 50% on the final exam. I mean, if you got less than 50%, I would consider that you didn't learn much that there. However, the difference between an 80% and 100% on the final exam is much more difficult to achieve right there. And that's where questions like question 5A, where I didn't tell you how to do that in class, and you're sitting there on the final exam, how do I do that? And you scratch your head a little bit. That's where I separate, the 90s from the 100s real quick right there. And part B is a little bit more straightforward. Part A is one there. So when you look at this final, I would do questions 1 through 3, because those are all straightforward. They're all essay questions. Don't write 10-page essays on a final exam. Write 1 page on an exam paper at most, right there. I can take one question here. Question 1C, discuss the various advantages and disadvantages of factory automation. You should include, I could write a 10-page paper on that right there. That there. Don't do that. Just kind of hit the highlights that there. And you don't have to say what I said. This is not, that is not a question where I want you to just repeat back what I said in class. But you just kind of give the highlights that, the economic effects are going to be that the company's going to make more money, blah, blah, blah. However, the effect on the community is, less jobs. You just kind of hit the highlights up there. And again, that's going to, if this was an assignment, and this may become an assignment actually for the transfer degree students in that session, that I make them write a 2-page or 3-page paper on that, because you could easily come up with a 2 or 3-page paper on that. So, but questions 1, 2, and 3 really should take about, I'd say, an hour at most for those 3 questions. And then you want to leave yourself at least 20 minutes for problem 4 and probably 40 minutes for problem 5 right there. Problem 5 is probably going to take as much time as problems 1 and 2 at least combined right there. So it's the more difficult problem 5. So just keep that in mind as you're doing the test. Don't get yourself hung up in problem 5 and you spend all your time. And don't write a 5-page essay for problem 1C right there. Just write a fairly straight, make sure it's clear that there, because again, if I read another question on here, mention, explain the various types of motors for robotics, including that there. Again, I could write a 1.5 pages on servo motors, how they work. But a servo motor, basically, you say a servo motor is one that goes between 0 and 180 degrees. It's controlled by X, blah, blah, blah. And again, that's the same question is actually in question 2. That there. See, actually, question 1A and question 2, A, B, and C, are really a repeat question right there. So keep that in mind that and I did that a little bit intentionally, but the same questions asked twice in different ways. That there, one place I simply explain the various types of motors. I don't necessarily want to get you for problem 1A. I don't want you to explain how to control these because I asked that in question 2. But I just want to know the various types of motors, the advantages and disadvantages of them. Part 2, I get into more specifics. How do you control them? Right there. But again, there's some overlap between question 1 and question 2 right there. So, without actually emailing you this document, which I'm not going to do, obviously, I think if I did that, then I would probably find that I would probably not be working here much longer because that would be giving out the final exam before the exam. Right there. That's really all the hints I can give you on the final, right there. That's everything I can tell you on the final. That's going to be on the final. That there, what? Yeah, that there. Well, it's funny because throughout every course, all I hear is what's going to be on the final, what's going to be on the final. So I just decided here at the end, I'm just going to tell you exactly what's going to be on the final. I actually read a number of the questions to you. That there. Of course, reading those questions means that you have to go through and research the answers between now and the final exam, right there. But at least probably a third of the questions of the final exam, I read the questions to you, right there. So it's not a difficult final, but it's not an easy final, right there. It's one that, and as I grade it, I will keep in mind that English is a second language for most people in this room, and you're going to be writing essay questions for at least a third of the final. That's going to be a little tough on you that there, but I don't think it's going to be a huge problem out there. So